Welcome. So today's topic of discussion is a basic introduction to metal cutting. Myself, Dr. Abhijit Bonik. So here we are starting. So when we are considering a metal cutting process, so let us start it from what is actually a manufacturing process, because metal cutting operations comes under your manufacturing process. So manufacturing, it is a value addition process that transforms a raw materials with low utility and limited value due to inadequate material properties, irregular size, shape, or poor finish into high utility products. This process ensures precise dimension, defined forms, and improved finishes, thereby enhancing their functional capabilities and overall worth. So, in gist, we can say manufacturing process transforms a low utility raw material into a high utility finished goods. So, approaches in manufacturing, so it can be categorized in two broad category, that is top down approach, also known as subtractive manufacturing, and bottom up approach, additive manufacturing, which is very popular nowadays. And also there are different types of manufacturing process: forming, casting, joining, welding, machining, powder metallurgy, sheet metal processing, finishing. So this is an overall uh, introduction to manufacturing process. Okay, so now we will enter into the domain of metal cutting. So what is metal cutting? Material is removed from the workpiece in the form of chips to achieve the required shape, dimensions, and surface finish. And it is a top down approach. So now we have to understand what actually top down approach means. So here we are removing from the top portion some material and we are gradually moving downwards. When it is in additive manufacturing, we are actually adding layers of materials, so we are moving from the bottom towards the upside. So metal cutting comes under the category of top down approach, where from the top surface we are removing material and gradually we are moving downside or downwards. Okay, so by material removal we are actually providing a particular shape, dimension, and surface finish which is our desire. So here what we are doing in metal cutting operations, say a raw material is provided to us, a raw material in the form of say some metal bar or metal block, and from that block we need to create a particular shape, and that shape should be of particular dimension, and the surface should be of particular surface finish. So that thing we will achieve through metal cutting operation by removing material in the form of chips. Now when we are considering metal cutting operation, few uh, important terms we need to know. So metal cutting operations are also known as machining process. So often we confuse between machining, and machine tools. So what is a machine? A machine is a device that transforms energy from one form into another, facilitating a useful work. So any device around us which transforms energy from one form to another can be considered as machine. But when it comes to machine tool, it is different. How it is different? Machine tool actually relates to metal cutting operation. What it is, how what is its role? Then the role is it that it grips both the cutting tool and the workpiece while facilitating their relative motion for machining operation. That is, when we are going for a metal cutting operation, we need a cutting tool which will provide the cutting operation, and there is a workpiece on which we are going to do the metal cutting. So we need to hold both of them firmly and also provide them a relative motion between them while contacting, make a contact between the cutting tool and the workpiece. So this whole thing will be done by an device that is known as machine tool. In machine tool we will hold both the cutting tool and the workpiece and provide a relative motion between them. Now what is cutting tool? A cutting tool is a wedge shaped instrument that extract pressure on the workpiece material during machining operation and gradually removing excess material through shearing, that is shear deformation, to achieve required shape, size, and precision. It remains in direct contact with the workpiece and plays a crucial role in material removal by applying force. So whenever we are considering metal cutting operation by cutting tool, it is important that we need to keep in our mind that the cutting tool should be in direct contact with the workpiece. So cutting tool will apply force on the workpiece, and that force will in terms it will provide some shear deformation, and that shear deformation will going to uh, result in removal of material from the workpiece material. So it is a very important point to be noted that in machining operation or metal cutting operation, cutting tool and workpiece are always in contact. So in order to remove workpiece material, that is from the material from the workpiece, there is a condition that we also need to know, is that cutting tool material's hardness should be always greater than the workpiece material hardness, because cutting tool is the one which is forcing the workpiece material and removing the removing the material from the workpiece. So always the cutting tool material's hardness should be greater than the workpiece material. If it reverses, that is if workpiece hardness is more, and let us assume there is a machining operation where workpiece hardness is more and the cutting tool hardness is less, at that time material will not remove from the workpiece, rather it may happen that material is removed from the cutting tool. So if we want to remove the material from the workpiece, then when we are selecting the cutting tool, the hardness of the cutting tool should be always greater than the workpiece. So this is a very important condition that we need to keep in mind. So as a whole, in this flow chart, we can see, if we want to want to understand the metal cutting operation, so there is a machine tool on which we will give some input in terms of some work material, cutting tool, and machining condition. Machining condition, that is the parameters of that machine tool, and ultimately at the output end we will get the desired product of desired shape, desired size or dimension, and surface finish. So this is in general we can say the machining process is. So now let us focus on to the cutting tool. So every conventional machining operation employs a physical cutting tool. So when we are considering here conventional machining operation, this is a new term, but I have already discussed this just in the previous slide. Conventional machining operation means this is a type of metal cutting operation where the cutting tool will be always in contact with the workpiece. If it is not, then it will not comes under conventional machining operation, rather non-traditional machining operation. Okay, in non-traditional machining operation we will see in further slides maybe that the cutting tool is not in contact with the workpiece, but in conventional machining operation the cutting tool is in contact with the workpiece and cutting tool is forcing the workpiece. That's why we need higher hardness for cutting tool. Although basic shape and feature of such cutting tool vary greatly with the type of operation it is intended to perform, every cutting tool mandatorily possesses a wedge shaped portion with sharp cutting edge. So here actually we are discussing the geometry of the cutting tool, and most of the cutting tools they have a wedge shaped, and there is a sharp cutting edge which will be in contact with the workpiece. Due to that sharp cutting edge, through that sharp cutting edge only material will be removed, which can assist shearing and thus cut material smoothly and efficiently. Now cutting tool can be of different types. Single point cutting tool, that is there will be one single main cutting edge which will be in contact with the workpiece. Then there can be double point cutting tool and multi-point cutting tool, that is there are two cutting edges or maybe more than two cutting edges will comes under the multi-point cutting tool category. So single point cutting tool for shaping, planing, turning operations we use this single point cutting tool where only a single cutting edge is there. Double point also there. Multi-point cutting tool for milling operation, drilling operation, there are multi-point cutting tools are there. Now here is a pictorial representation of different types of tools. Here in the first two image we can see it is a single point cutting tool. Here the one of the edges will only be used for material removal, so it will come under the category of single point cutting tool. In the below we can see the drill bit which have two cutting edges, so it may comes under your double point cutting tool. And there are some milling cutters also. Here we can see multiple cutting edges are there, more than two. Now it is a here is a difference between the single point cutting tool and a multi point cutting tool. So in terms of number of cutting edges, single point cutting tool will be having only single cutting edge. Multi point cutting tool contains multiple, more than two maybe. Then material removal process removes material continuously with one edge, and for multi point cutting tool removes material simultaneously with multiple edges. Now this is very important point and it needs some discussion, that when it is a single point cutting tool, the cutting edge is continuously in contact with the workpiece. When it is a multi-point cutting tool, then each and every cutting edge has to come in contact with the workpiece. So there will be discrete contact of cutting edges with the workpiece. That is, one cutting edge will come in contact with the workpiece, it will remove some material, then it will shift, and new cutting edge will come in contact with the workpiece, and it will also remove the material from the workpiece. Like that, cyclically all the cutting edge will come in contact with the workpiece and will remove. But in case of single point cutting tool is in continuously in contact with the workpiece, and through that single edge only material will be removed continuously. So here we can understand one thing, that in single point cutting tool the load or stress on the cutting edge is more, whereas in multi-point cutting tool the stress will be divided through all the cutting edges. Okay, so from that point of view we can understand that the your lifetime, or the time that can that is the longevity of the multi-point cutting tool is more. Okay, so example of single point cutting tool is turning tool, shaping tool. Multi-point cutting tool is milling and drill bit. Surface finish, it provides a relatively smooth finish for single point cutting tool since it is in continuous contact, whereas in multi-point cutting tool offer better surface finish depending on the tool geometry, since continuously there is a engagement and detachment, so there is a chance that surface finish may not be that good as for your single point cutting tool. So cutting speed, if we consider cutting speed, single point cutting tools are preferred with low cutting speed, because here only a single cutting edge is there and it is continuously in contact with the workpiece, so there is a lot of stress and load on that single edge only, so we prefer to operate a single point cutting tool at lower speed, whereas multi-point cutting tool can handle higher speeds also. Heat generation, more heat will be generated because it is a continuous contact, and less heat for multi-point cutting tool because there is a continuous engagement and disengagement, and whatever heat is there it will be shared by all the edges. Tool life, obvious that single point cutting tool will be having lower tool life and longer tool life for multi-point cutting tool. Application wise, if we consider, then it is shaping, turning and planing operation we use a single point cutting tool. For multi-point cutting tool, milling and drilling and grinding operation is also there. So here is a classification of material removal process. Here you can see traditional and advanced. There are two broad categories of material removal process. Advanced material removal process can also be sometimes categorized as non-traditional or non-conventional machining operation. So in what term these two actually differs? Traditional, in traditional machining operation, metal cutting tool is in direct contact with the workpiece, and cutting tool is forcing the workpiece. Okay, force will be applied through the cutting tool on the workpiece through direct contact, whereas in case of non-traditional machining process, the cutting tool or the source of cutting will not be in contact with the direct contact with the workpiece. Okay, so here is a bit discussion is required, but due to the limitation of this slide, I will not go through this non-conventional machining process, but the main main point is that in case of advanced or non-conventional machining process, cutting tool will not be in direct contact with the workpiece. Now let us focus on the traditional machining material removal processes, that is cutting and finishing. Cutting means bulk material will be removed, and finishing means material removal will be in smaller fraction. So finishing means for surface finish. So in cutting we can cut circular shapes like cylindrical one. For that turning, drilling and boring operations are there. For prismatic shape, that is flat shapes, so flat surfaces, if we want to produce, then there are milling operation, shaping and broaching is there. Then for finishing, if it is a bonded abrasive, then grinding, honing and coated abrasive is there. And for loose abrasive, there is lapping and finishing. So this is the overall generalized classification of material removal process. So with this we will conclude here. So from here we can understand a very basic introduction to the material removal process, where we learned what is cutting tool, what is machine tool, what are the different types of material removal process, what is the difference between advanced and traditional machining process, then what is the difference between machine tool and cutting tool, what is the difference between single point cutting tool and multi point cutting tool. Thank you.